The recurrence relations in a geometric sequence or arithmetic sequence refer to just the most previous term, right? So it's taking the previous term and multiplying it by 1/3. Down here it's taking the previous term and subtracting 5. So it's just really referring to the most previous term. But you can have recurrence relations that actually refer to more than one previous value. And a really famous one of these is the Fibonacci sequence, and we've seen that before, right? And the definition for Fibonacci, well, this is only part of the definition, right? We're going to flesh out the rest of it. But part of the definition of the Fibonacci sequence is that f of n, so that this term is equal to the previous term, n minus 1, and the term before that. So it's actually referring to two previous terms. So in this case, we can compute lots of the terms, but we have to know actually how many terms. In the other ones, we only needed to know one, right? It just says, okay, well, what's the very first term? Once we have the first term, we can keep going. But in this case, we actually have to know the first two terms because it goes back to the two previous ones. So we have to be able to define the first two. So let's go ahead and start with an initial index of 0. And then we have to define, well, what is f of 0? And this has to be given to us. So part of the definition of the Fibonacci sequence is what that initial one is. And the first value in this series is 0. And then the next one, if the initial index is 0, the next index is 1, right? Because we always know that the sequence, their indexes are consecutive, then this is 1. Now this is almost fully defined. This identifies what it is f of 0. This is f of 1. This is the rule for f of n for everything greater than 1, right? So we can say that for all n that is greater than or equal to 2. All right, now that's fully defined. Now we have enough information to write this entire sequence, right? What's the first term in the sequence? It's 0. What's the next term in the sequence? It's 1. What's the next term? It's the previous value plus the one before that. So it's 1 plus 0, which is 1. And now what's the next term? Well, the next term is defined by the previous one plus the one before that. So it's 1 plus 1, which is 2. What's the next term? It's the previous value plus the one before that, so it's 3. So now you can continue to define it because we have this recurrence relation that tells us how to compute the next term in the sequence. And we could just keep going and computing those terms. Notice that this gets off to a slow start, but once you get going, it picks up pace pretty fast, right? Now it starts getting bigger pretty quickly, and you see it growing, right, exponentially. So that's a really famous recurrence relation. Now notice when you're doing recurrence relations that you really have to pay attention to what terms are being looked to, and so how many terms do you have to know. So consider this less famous recurrence relation, and notice that it's referring to, it doesn't even actually refer to the most previous term. There's no b to the n minus 1, but it's b of n minus 2 and b of n minus 3. So it goes back the second most previous and the third most previous. So for this one, how many terms have to be defined, right? We're not referring to the one most previous, but we need to know the one before that, and we need to know the one before that. So we actually need to know back 3 previous ones. So to get this one to be fully defined, we have to define the first one. So I'm going to start with an index of 1. So what is the value of the first one? Well, we're going to start it out at 0. So the first one's 0. And then the next one is b of 2. And what's it equal to? Well, for this relation, it's also equal to 0. Notice that the terms themselves don't have to be consecutive, don't have to always increase. Notice with the Fibonacci that here we have a space where it's exactly the same, right? That same term repeats. So there's no rule about the terms in the sequence. The only rule about being consecutive is with the index. Now this one, is this increasing or decreasing? So it's almost increasing, right? It's increasing here and it's increasing here, but notice it's not increasing at this one spot. So that means this is not increasing. What it means is it's not decreasing, right? It never decreases. So we could say, oh, it's not decreasing, but it's not increasing because there's this one spot where it's not increasing. So this one would be a sequence that is non-decreasing. All right, let's look at this one. We need one more term, right? Because this is, we need 3 and we only have 2. So let's do the next one. B of 3 equals 1. Okay, so there's our 3 values. Now we can write this. And so this is the rule for B1. This is the rule for B2. This is the rule for B of 3. What's the rule for everything else? This is the rule for everything else. And how do we say everything else? We say for n greater than or equal to 4. And that's for everything else. So let's go ahead and write this relation, or write the sequence. Sorry, we've got the relation fully defined. Now let's write the sequence. The first term is 0. The second term is 0. The third term is 1. What's the fourth term? It's b of n minus 3. What index are we at now? We're at index 4, right? Let's go ahead and write the indexes above here. This is index 1. This is index 2. This is index 3. This is index 4. Do index 5 and index 6. Okay, let's just do that many. So now we're at index 4. So b of 4 minus 3 is b of 1, which is 0, plus b of n minus 2. So 4 minus 2 is 2. So that term at index 2 is 0. So it's actually 0 plus 2 times 0. So this term at index 4 is 0. Okay, what is it at index 5? So at index 5, it's b of 5 minus 3, which is 2. So that's 0, plus 2 times b of n minus 2, which is 5 minus 2, which is 3. So it's going to be, which is 1. So it's 0 plus 2 times 1, which is 3. Okay, what's the next one? 6 is the index. So we want to look at b of 6 minus 3, which is b of 3. That value is 1, plus 2 times b of 6 minus 2, which is 4. So it's 2 times 0. So what do we have? We have 1 plus 2 times 0, which is 1. Now, is this sequence increasing? No, we have these spots here. This case, it's not increasing. In this case, it's actually decreasing, right? So we can't even say it's non-decreasing, right? Because it stays the same, it goes up, it goes down, it decreases, it increases, it decreases, right? So this is non-decreasing and non-increasing. So, but notice how this is fully defined, and we can continue to identify what the next term is using this recurrence relation.